Hello class, my name is Zoe Chilcote and I'm going to be teaching you guys about transform plate boundaries. So, plate tectonics cover the Earth, and the 9 major plates are the Eurasia Plate, Pacific, India, Australia, North America, South America, Africa, and Antarctic. All these plates are in constant motion, even though we don't feel it because it is very slow motion in comparison to how fast we move as humans. And these plates also move in a rotational manner. There are 3 different types of plate boundaries where all of these plates meet. And I'm just going to briefly go over those 3 before we go into the transform plate boundaries. So there is divergent, where the plates are moving apart from each other. There is convergent, where the plates are moving together, and then transform, where they're moving side by side, like this. And I'm up in the top corner, making hand gestures if you would like to see. So transform plate boundaries are where one plate slides along another, but it's without creating or destroying the crust on those plates. Most are found in the ocean and the mid-ocean ridges, and of course they are ocean-to-ocean plate boundaries, and they are less common than convergent and divergent boundaries as a whole on Earth. So it is very hard to identify a transform plate boundary, and sometimes there is no indication of their presence at all. Sometimes you can look close and find linear fault scarps along these ridges to find evidence that they exist, but there are no mountains, volcanoes, or rift valleys to indicate that they are there like in the other boundaries. An example of a transform plate boundary is the San Andreas Fault, and it's in the Gulf of California. It extends from the southern end of the Juan de Fuca Ridge to the northern end of the East Pacific Ridge, and it separates the North American plate to the Pacific plate. Los Angeles, which is on the Pacific plate, south on the Pacific plate, will eventually be parallel to San Francisco, which is on the North American plate, because of the sliding motion that will happen between these 2 plates. And this motion causes earthquakes. An example of an earthquake that happened in San Andreas is the one that happened in 1906, and it created a fire that lasted 3 days, and it killed more than 500 people. It left 250,000 people homeless, and it destroyed 500 city blocks. If an event like this were to occur now, the destruction and the impact would be way more, because it is a way more highly populated area than it was back in 1906. So although this seems bad, it would be way worse if it were to happen now. So let's hope it doesn't. Another example of a transform plate boundary is the Caribbean plate boundary, and is on the northern edge of the Caribbean plate, and it's between that and the North American plate. You'll find that transform boundary. It caused a magnitude 7 earthquake in 2010, which struck Haiti, and that impacted 3 million people and caused major destruction in Haiti, and I'm sure they're still rebuilding from that destruction today. So many of these transform plate boundaries are found along ocean ridges, and they are small transform boundaries that occur along the ocean ridges, and they create shallow earthquakes underwater. These boundaries are very essential to moving these 2-dimensional plates on a 3-dimensional Earth. So think about trying to wrap a ball for Christmas for your little brother, and how many times you have to cut that paper in order to wrap the ball versus if you were wrapping a box. And so all of these little transform boundaries are like tears or cuts in the paper that help smooth it over Earth, which is round. All right, so here's some pictures that I have. This first picture here, let's do a laser pointer. This first picture here is just some of the outlines of the boundaries that we have on Earth. The transformed plate boundaries are in black in this picture. This picture doesn't do a great job of showing the ones in the ocean because they're very small, but that's okay. Up here in this corner, we have just a little visualization of the motion that transformed plate boundaries cause. So here's an in close picture of the little boundaries, transformed boundaries that are along the ocean ridges in this bottom corner here. And so that picture does a better job of showing those little tiny boundaries that are along these big boundaries in this picture. And then this picture over here is just showing the San Andreas Fault, dividing the Pacific plate with a little bit of North America on it, with the North American plate, which majority of North America is on. And that is the end of my PowerPoint presentation. I hope you guys enjoyed and maybe learned a little bit. Thank you for listening. Okay, can it stop?